Hello everyone, myself I am Srivalyadia from Sri Venkateswara College of Engineering, Bengaluru, pursuing in Science CSC Chanakya, subject Digital Design. Topic Project Based Learning Experience in Vhdl Digital Electronic Circuit Design. Introduction to Project Based Learning. Project based learning emphasizes the hands on experience and the real world applications. It encourages the students to engage deeply with the subject matter through projects. PBL fosters critical thinking, collaboration, and it also problem-solving skills among learners. Overview of VHDL. Here, VHDL stands for VHSIC Hardware Description Language, and it is used for digital circuit design. Here, VHDL allows the designers to model and stimulate the behavior of electronic system. It helps for the understanding the VHDL is essential for implementing efficient and reliable digital circuits. Importance of VHDL in education. VHDL training prepares the students for careers in electronics and embedded systems. It provides a solid foundation and in digital design concepts and practices. Learning VHDL enhances the students' employability and helps the rapidly evolving tech industry. The role of PBL in VHDL learning. PBL integrates the theoretical knowledge with the practical skills in VHDL applications. Here, it enables the students to work on real-world projects, fostering engagement, and PBL encourages the collaborative learning and enhancing the communication and the teamwork. Here, gold stand PBL. Here we can see the 7 project-based teaching practices, in which is design and plan, aligns to stands, build the culture, manage activities, scaffold student learning, assess the student learning, engage and coach. Defining the project goals. Clearly here define the goals guide the direction of the VHDL projects. Goals should be specific, measurable, achievable, relevant and time bound. A well-defined project scope ensures the focused learning and effective outcomes. Here S stands for specific, what is my goal? M stands for measurable, how will you track your progresses? A for achievable, is your goal is realistic? Or for relevant, does the goal align with the overall plan? T for time bound, given you are deadlines. You goal to a deadline. Here, the selecting the project topics. These topics should be reflect current trends and challenges in digital design, and students should be encouraged to choose the projects that align with their interest and collaboration with the industry professionals and get help in topic selection. The procedure of topic selection for research is generation of ideas and identification of own interests and checking the requirement and the selecting a wide field for research and analyzing the books and articles and determining the relevance of the topic chosen. Research and planning phase. Students conduct the research to understand the project topics. Planning involves outlining the project milestone and identifying the necessary resources. And this phase is critical to ensure the effective time management and resource allocation. Phases of project management is there are 5 phases, which is initialization, planning, execution, monitoring and control and close. Here again we can do the project management. Designing the circuit. Students should create the schematic diagrams to visualize the circuit design. VHDL code is developed to describe the behavior of digital components. Iterative designs allows for continuous improvements and refinements. Simulation and testing. Simulation tools helps to validate correctness of the VHDL design. Students learn to troubleshoot and debug their design during this phase. Testing ensures that the circuit functions as intended and before physical implementation. Implementation phase. Here the student should use the programmable devices such as FPGAs to implement their design. This phase allows for hands-on experience with their real hardware. Implementation of the bridges the gap between the theory and practice is in digital design. Here we can see the design entry and the design implementation and the device programming. In design entry, we should do the schematic capture and the language-based entry. Functional simulation. Verify the correct logic functionality and estimated time or non-timing. Design implementation. Design translation and synthesis. Design rule checking, logic partition, of fitting or block placement or routing, create programming file. Time, Timing simulation, post placement timing info, static time analysis, post placement timing info, faster results than timing simulation. In system debugging for reprogrammable products used with the other system, software and hardware design verification. Collaboration and the teamwork. Teamwork is integral to PBL, promoting the diverse perspectives and skills. Students should learn to communicate effectively and manage the group's dynamics. Collaboration enhances the creativity and leads to innovative solutions. Documentation and reporting. Proper documentation is essential for reflecting on a project, processes, and the outcomes. Students learn to create comprehensive reports that outline their work. Documentation fosters the accountability and can serve as a resource for future projects. Here we can see the projects as the meeting notice, requirements, planning, others, and the tasks. Presentation skills development. Presenting the projects helps the student to articulate the design process and their findings. Effective presentation skills are crucial for professional success in any field. Students gain the confidence in public speaking and explaining the technical concepts. Challenges faced in PBL. Students may encounter their technical difficulties during the circuit design and implementation. Time management can be a challenge when balancing the multiple projects, components, group dynamics may lead to the conflicts that require the resolution strategies. Benefits of PBL in Vhdl education. PBL enhances the retention of knowledge through practical application. It prepares the students for real-world challenges they will face in the workforce. Students develop a sense of ownership and their pride in their completed projects. Case study, student projects. Highlight successful student projects that utilize VHDL in digital design. Discuss the innovative solutions developed through the PBL approach, and it analyze the impact of the projects and the student learning and the engagement. Feedback and reflection. Gathering the feedback is crucial for improvement and the growth in PBL experiences. Reflection helps the students to evaluate their learning process and the project outcomes. This phase encourages the continuous learning and adaptation in future projects. Future of VHDL education. The demand for VHDL skills expected to grow in the tech industry. Integrating the emerging technologies into VHDL projects can enhance the learning. Educational institutions should embrace the PBL to keep with the industry needs. Conclusion. Project-based learning in VHDL fosters a deeper understanding for digital design concepts. It equips students with the essential skills for the future careers in the technology. By engaging with the real-world problems, the students become more innovative and prepared. Questions and discussion. Open the floor for questions regarding the PBL and approach the VHDL. Encourage the discussion of potential improvements and the future project ideas. Gather the insights of participants to enhance the learning experience further. Thank you.